Hello, this is Mrs. Bentley. I am going to work on the released EOC questions 6, 7, and 8 with you. If you notice, questions 6 through 15 require you to write your answers in the boxes provided on your answer sheet. Well, this does not apply to us because our school does test online, so you will have to enter your answers. This is an open-ended question. This is also in the No Calculator section of the test. So number 6 says, two boys, Sean and Curtis, went for a walk. Sean began walking 20 seconds earlier than Curtis. Sean walked at a speed of 5 feet per second. Curtis walked at a speed of 6 feet per second. For how many seconds had Sean been walking at the moment when the two boys had walked exactly the same distance? So I notice at the beginning of the problem, they state that Sean began walking 20 seconds earlier than Curtis. And one of our bullets tells us that Sean walks at a speed of 5 feet per second. So if we think about for 20 seconds and 5 feet per second, 20 seconds times 5 feet would equal 100 feet. Curtis walked at a speed of 6 feet per second. Our question asks, how many seconds had Sean been walking at the moment when the two boys had walked exactly the same distance? So we are going to write, since they're walking at a rate of change of either 5 feet or 6 feet per second, we are going to write a linear equation for each boy. So Sean's equation is going to be y equals the speed he's increasing, or amount of feet he's increasing per second is 5 feet per second, and he is already at a 100 feet head start. Curtis, his equation is just going to be y equals 6 feet per second. If you need to see a y-intercept, his y-intercept would be 0. Again, this is because Sean has the head start. We are trying to see when the two students will be at the same distance, so we are going to set Sean's equation by substituting equal to Curtis's equation. So we are going to write the equation 5x plus 100 equals 6x plus 0. So notice we have x on both sides of our equation, so we need to use an inverse operation to combine our x's. I'm going to move my 5x by subtracting 5x on both sides. My 5x's cancel, leaving me with 100 equals 6x minus 5x is x. And again, we don't need to bring down the 0. So we have the x equals 100. So Sean had already been walking 20 seconds, and we have now found that it would take 100 seconds for Curtis to catch up to him. The question asks for how long had Sean been walking. So we will take his 20 seconds and add to the 100 seconds we found when we were solving for a total of 120 seconds. Okay, and number 7, the math club sells candy bars and drinks during football games. 60 candy bars and 110 drinks will sell for $265. 120 candy bars and 90 drinks will sell for $270. How much does each candy bar sell for? So we have two different scenarios. We have our candy bars and we have our drinks, our candy bars and our drinks. So I'm going to define variables, and I will use C to represent candy bars, and I will use D to represent drinks. So now we can use our variables. This is C, D. So we would write 60 candy bars plus 110 drinks equals $265. 120 candy bars plus 90 drinks equals $270. Now keep in mind, this problem is on the no calculator part of the test. And notice we have a system of linear equations. The way the equations are written, the easiest method would be elimination. The best way to do elimination is when we have opposite coefficients of one of our variables. I noticed there is a relationship between 60 and 120. So if I want to get smaller numbers to work with, I could go through my bottom equation and divide everything by -2. If I divide by -2, 120 divided by -2 is going to simplify to -60c. Notice this is now the opposite coefficient of the 60 in our first equation. If I divide 90 by -2, that's going to equal -45d. And if I divide 270 by -2, well, let's do a little bit of math here. We know it's going to be a negative. 2 goes into 2 one time. 2 will go into 7 3 times with a remainder of 1. And then 2 will go into 10 5 times. So -135. I'm going to recopy the top equation underneath. So 60c plus 110d equals 265. I do want to make note, if dividing by -2 is confusing to you, you could also multiply the top equation by -2. Just keep in mind those numbers are going to be a little bit larger to operate with, and I was trying to make this smaller since there is no calculator. We have our opposites, so we're going to do elimination by addition. -60c plus 60c is 0. -45 plus 110. Well, let's see, 5 will make this 50, and then 50 would get us to 100, so that's 55, and then 10 more, so this is going to come out to equal 65d. And 265 minus 135, so 265 minus 100 is 165. 165 minus 135 leaves me with 130. We're going to continue solving for d. So to undo this multiplying, we're going to divide both sides by 65. Cancel that out. So d equals, well, 65 goes into 130. Let's kind of think through this. Well, 60 plus 60 is 120, and 5 plus 5 is 10, and 120 plus 10 is 130, so 65 goes into 130 2 times. So the cost of a drink is $2. Now let's look back at the question. The question does not ask for the cost of the drink. The question says how much does each candy bar sell for? So we need to now substitute 2 in for d into one of the original equations. I'm going to use the top equation. So here where I see my d, I'm going to substitute in my 2. So this is going to be 60c plus 110 times 2 equals $265. Now we're going to simplify. So this is 60c. 110 times 2 is 100, actually 200, sorry about that. 220 equals 265. Okay, our next step, we're going to subtract our 220 from both sides. So subtract 220 on both sides of the equation. 220 minus 220, that's 0. We still have our 60c, so bring 60c down. And 265 minus 220 is 45. We're going to divide both sides by 60. Again, we're still not using our calculators. So this is going to give us c equals 45 over 60. Okay guys, so what we need to start thinking about is, can we reduce this fraction? If we can reduce this fraction, we'll eventually have to convert to a decimal because the problem did instruct us to enter our answers as a decimal representing dollars and cents. I know 45 and 60 are both divisible by 5. I'm trying to think if there's a larger factor. Let's see, 15 will also work. So we can divide 45 by 15. We can also divide 60 by 15. 45 divided by 15 is 3. 60 divided by 15 is 4. And 3/4 as a decimal is 0.75. 0 represents dollars, 7.75 represents cents. So the cost of the candy bar is 75 cents. Okay, on number 8, what is the smallest of 3 consecutive positive integers if the product of the smaller 2 integers is 5 less than 5 times the largest integer? We did this problem together in class on Friday, but I'm going to work it out one more time for you in case you missed writing it down. So again, consecutive integers. X will represent the first. Consecutive just means it's going to increase by 1 more each time. So the second is x plus 1. The third would be x plus 2. It says the product. Product means multiply of the 2 smaller integers. So x and x plus 1 will be our 2 smaller integers. So we're going to multiply those 2 small integers together. Here's our keyword is 5 less than. Remember, you're going to subtract at the end. So you need to do 5 times the largest integer and then subtract 5. We're now going to clean this up by using our distribution rules. So x times x is x squared. X times 1 is plus x. On the right, 5 times x, 5x. 5 times 2 plus 10, and bring down the minus 5. We have like terms, positive 10 and negative 5. We can combine, so this side now simplifies to 5x plus 5. As soon as you recognize that you have an x squared, that's an indicator that we have a quadratic equation, so we need to move everything to one side to write this in standard form. So I'm going to subtract 5x on both sides. We can combine like terms, so this simplifies to x squared minus 4x. We also need to subtract the 5 over, and that's now going to equal 0. I notice I have a quadratic equation. It is a trinomial. There is no GCF, so I'm going to use my Xbox method. Okay, A is 1, C is negative 5. 1 times negative 5 equals negative 5. B is negative 4, so we need factors of negative 5 that will give us a sum of negative 4. And that is going to be negative 5 and positive 1. Okay, now we're going to box it. So in our box, we're going to use our x squared. We are going to use the 2 numbers we found from our x table, the 2 side numbers. So we're going to use our negative 5x, our positive x, and our constant. You always keep this first term and this last term in your box in negative 5. The GCF of the first column is x. The GCF of the second column is negative 5. The top row, x. The bottom row, positive 1. So our 2 equations are x plus 1 equals 0 and x minus 5 equals 0. If we solve for x on each equation, the first equation will subtract 1, so x equals negative 1. The second equation, we will add 5 to both sides, so x equals 5. Now make sure you look back at the original question. It says, what is the smallest of 3 consecutive positive integers? So that means the negative solution is extraneous, so we'll cross that out. So x equals 5, that's our first number. 5 plus 1, here you would substitute 5 plus 1, so the second number is 6. And 5 plus 2, so the third number is 7. They only want the smallest of the 3 numbers, so your solution is 5.